All right, so the focus for day 3 is to revisit the idea of radian measures that we just briefly talked about the previous day. Previously, we had just talked about how to convert from radians to degrees and what the radian is equal to and what's the definition of a radian. So today we're going to focus on special radian measures and what are called something that's called reference angles. Now, I want to look at this drawing, this circle over here, and you see that there are um, degree measurements and its corresponding radian measurement. So you have 30 degrees, 45, 60, 90, 120, and so on, all the way to 360. And then the equivalent radian measures pi over 6, pi over 4, pi over 3, pi over 2, and 2 pi over 3, 3 pi over 3 pi over 4, 5 pi over 6. Now, what we're going to focus on a lot today is the idea that 0 degrees and 0 radians are the same measurement. Whoops. We have 90 degrees and pi over 2, and that is our first quadrant here. From 0 degrees to 90, that's in quadrant number 1. So any radian measure that's smaller than pi over 2 is in quadrant 1. Then we have 180 and pi. So half a circle is 180 degrees, which is pi radians. And then we have 270 degrees, which is equal to 3 pi over 2. And then finally, a full circle is 360 degrees, or 2 pi. So you really need to understand these quadrant angles. The boundary for the first quadrant is pi over 2. The boundary for the second and third quadrant is pi. The boundary for the third and fourth quadrant is 3 pi over 2. Now, you do need to know the radian measure and equivalent degree measure. So one of the ways I like to think about that is the 30 degree has a pi over 6, pi over 6 denominator, and they add up, 3 plus 6 is 9. And then 60 degrees goes with pi over 3. 6 again, 6 plus 3 again is 9. So that works, for the first quadrant, but as you see over here, that relationship isn't necessarily there. We're going to talk more about ways you can remember these degree and radian measures, but for now we're just going to introduce this. And then we have 45 degrees is pi over 4. And then that's our first quadrant. And we can get the angles in the second, third, and fourth quadrant by multiples of these. So for example, pi over 6. 5 times pi over 6 is 5 pi over 6, and 30 times 5 is 150. So that's what we have written over here, but if we memorize all the radian measures in the first quadrant, and for 90 degrees, we can find the others by using multiples of those angles. Now you might say, well, what if we did times 2? Why would we multiply by 5? Well, 30 times 2 is 60. We already have that. Pi over 6 times 2 is 2 pi over 6, which reduces to pi over 3. We already have that. So it's something that we're going to be exposed to a lot this unit, and it will become easier to memorize these. You may notice that all of the angles that end in a 5, let's use a different color, all the angles that end in a 5 have a denominator of 4. So that might be something that's useful to know. The numerators, like in the first quadrant, the numerator is all 1. And then in the second quadrant, the numerator is 1 smaller than the denominator, if you look at all that. And then quadrant number 3, the number in the numerator is 1 bigger than the denominator. 7 is bigger than 6. 4 is bigger than 3. 5 is bigger than 4. And then so on. And then in quadrant 4, the numerator, this one's a little bit harder. the numerator is 2 times the denominator minus 1. So like 3 times 2 is 6, minus 1 gives you 5. 4 times 2 is 8, minus 1 gives you 7. 6 times 2 is 12, minus 1 gives you 11. And these radian measures go in order too. 6, 4, 3, 2, and then reverse, 3, 4, 6. And then we get pi. Then it goes reverse again, 6, 4, 3, then 2, and then 3, 4, 6 again. So we'll come back to this in the next couple of days, but I just want to get us primed a little bit to understanding the equivalent radian measures to these angle measures in degrees and how we can estimate where angles are without looking at this all the time. So example 1, draw an angle with the given measure in standard position, then find one positive coterminal and one negative coterminal. Well, 2 pi over 3, to draw that, we know it is bigger than pi over 2, which is 90 degrees, but it's smaller than pi, because 3 pi over 3 would be pi. So we know it's going to be something like that. And this is our theta, our angle measurement. Now for the coterminal angles, we have to add 2 pi. Well, adding 2 pi, we can't just say, oh, 4 pi over 3. These do not have the same denominator. So we need to figure out that 2 pi is how many pi over 3? Well, multiply 2 times the denominator. 2 times 3 is 6. So 2 pi is equal to 6 pi over 3. So instead of adding 2 pi in this form, I'm going to add 2 pi in the form of 6 pi over 3. So 8 pi over 3 is a positive coterminal angle. And subtracting 6 pi over 3 gives us negative 4 pi over 3. So remember, coterminal angles have the same terminal and initial side, but the amount of rotation is different. That's the only thing different about those. Like if I were to draw both of these angles, the starting point would be right here, and the ending point would still be right here, but the amount of rotation would be different. All right, now 11 pi over 6. That's really close to 12 pi over 6, which is 2 pi. So it's almost going to be a complete circle. So almost a complete circle, and it's going to go this way. Now, 2 pi in this form is 12 pi over 6, because 6 times 2 is 12. So I'm going to take my 11 pi over 6 and add 12 pi over 6. That's 23 pi over 6. And my 11 pi over 6 minus 12 pi over 6, which is negative pi over 6. All right, now, letter C is a toughie because it's a negative angle. So remember, negative angles go clockwise, not counterclockwise. So instead of going in this direction, 5 pi over 6, I'm going to go in the other direction, 5 pi over 6. And the weird thing, or I guess the nice thing about pi, is that positive pi and negative pi are at the same place. If I do half a circle, it doesn't matter if I go this way or if I go that way, I still end up here. So this negative 5 pi over 6, I'm going to start in the positive x-axis, and it's almost going to be a half circle going this way. So that's going to be my theta. And again, I'm going to take my angle and add 12 pi over 6. That's 5 pi over 6. Oops. And take my angle and subtract 12 pi over 6, which is negative 17 pi over 6. So again, like these I know these angles are angles that we could have just copied from up here, but I want us to start and visualize where these angles are, what quadrant we are in. Just it'll make things easier down the road. All right, on the next page, we're going to talk about something called reference angles. So a reference angle for any angle theta is the acute angle, so remember that's less than 90, formed by the terminal side and the x-axis. Reference angles relate the given angle to its corresponding angle in the first quadrant. So reference angles are similar to coterminal angles, but the reference angle just tells you kind of what its spacing or what family it is in, and that'll make more sense in a moment later on when I talk about families. But the reference angles will tell you some information about your angle that you're asked about, but not everything. Whereas a coterminal angle is in almost an exact copy of the original angle, just with the different amount of rotation. So, for example, all of these angles up here have the same terminal and initial side as the original one, but with different rotations. Whereas the reference angle for each one of these angles is not going to be exactly in the same spot, because your reference angle is always going to be in the first quadrant, but there are some characteristics that we can talk about using the reference angles that apply to these original angles here. So the reference angle, again, since it's acute, your reference angle is always a quadrant 1 angle. And the way I like to think about it, it's the angle, or so the distance. I don't want to use distance because the rotation needed to get to the nearest x-axis. So that nearest x-axis might be I have to rotate further than where I stopped, my angle is. I may have to go backwards, or I may have to make a full circle. So these formulas, I would not put too much stress on memorizing these formulas, because in my opinion it's just easier to um, think about these, because that'll make life a lot easier instead of trying to memorize 3 more things. So if we look at an angle in quadrant 2, and you may ask, what about quadrant 1? Well, in quadrant 1, the reference angle is that angle itself. So like the reference angle for 44 degrees is 44 degrees because it's the acute angle in quadrant 1. But if you're in quadrant number 2, if your angle is in quadrant 2, like 130 degrees or 3 pi over 4, our reference angle, is how much rotation do we need to touch the x-axis right here. That is your reference angle. So if you think about it, if you have a half circle, which is 180 degrees, and I subtract my original angle, that gives you the reference angle. And that's where these formulas come from. 180 minus theta and 1 pi minus 180. Those will give you the reference angle. Now in quadrant 2, again, if this is our angle all the way here, it's more than 180 degrees because we're in quadrant 3. So if we had a half circle, let me use a different color. So if we have a half circle, how much more rotation is needed to get to the nearest x-axis? Well, this much. Because the nearest x-axis, I passed it. I got to go backwards. So if I take the whole angle given and subtract half a circle, I'm given this part right here, which is the reference angle. So it's going to be the angle minus 180. In quadrant 4, okay, if this is your angle, how many more degrees do I need in order to get to this nearest x-axis that'll be a full circle? I'm trying to find out what this is here. That's my reference angle. So if I have a complete circle here, and I take away this purple part, then I get my green part, the reference angle. So that's why it's 360 minus pi, 360 minus theta, or 2 pi minus theta. So let's look at some examples of this. Some examples down here. We're going to sketch the angle and then find the reference angle for theta. So negative 165. Again, that's almost negative 180 degrees, so it's almost half a circle going in this direction. So my reference angle, and if you can do this intuitively without showing work, that's fine. How many more degrees do I need to get to that x-axis right here? That's what I'm trying to figure out. You may say, oh, it's got to be 15 degrees. You may say, well, it's got to be negative 15 degrees because we're already going in the negative direction. Well, negative angles are not acute, and they are not in the first quadrant. So you would be right in saying positive 15. Or if we did 180 minus 165, that is going to give us 15 degrees. So how many more degrees do I need to get that half circle? 15. Now 7 pi over 4. Okay, 7 pi over 4 is almost 2 pi, so it's this right here. How much more do I need to get to this x-axis? Well, we know that a full circle is 2 pi. And if I take away my angle that I drew, my theta, I will get that purple part. So 2 pi minus 7 pi over 4. Well, that's 8 pi over 4 minus 7 pi over 4, which is pi over 4. That's my reference angle. Now, the neat trick with radians is that your reference angle is always going to be 1 pi over that same denominator, so 1 pi over 4. If I was in quadrant number 3, up here, quadrant number 3, 5 pi over 4, the reference angle would still be pi over 4. 7 pi over 6, the reference angle would be pi over 6. So it's really nice when it comes to radians using those reference angles. All right, the letter C, 150 degrees, again, is almost 180. So this is our theta. And how much more do we need to go? Again, if you know it's 30, then awesome, just write it down. Or you can do 180 minus 150 and get 30 degrees. That would be our reference angle. And then lastly, 5 pi over 3 is almost 2 pi. So that's our theta. And then again, if it's in radians, in pi radians, the denominator is 3. The reference angle is pi over 3. Because if we were to add pi over 3 to 5 pi over 3, that's 6 pi over 3, which would be a full circle. All right, so this idea of reference angles is going to keep coming back to us. So if you don't get it now, that's fine. We're going to keep repeating it. But if you need to rewatch some things, ask questions. But that's going to be it for today. Make sure to like the video and subscribe.